Well, alrighty, today we're going to be discussing, well, in several different videos, what are called the non-parametric tests. This is all chapter 13 stuff. Parametric tests. And for the most part, they're based on rankings. Not 100%, but for the most part. The idea behind them is that sometimes when you're in a race, for instance, you came in first place, and the guy behind you came in second place. First place in a race between, I don't know, the guys on The Biggest Loser and a 100-yard dash. Like, I won a 100-yard dash. I was racing against these guys from The Biggest Loser. Well, that's not saying anything. But I won by like 90 yards. Again, it's not saying anything. To say that you came in last in a race involving Usain Bolt at the Olympics, that isn't saying anything either, because you pretty much could have hobbled down on crutches and come in last place against them guys. So the idea between these things is that the times, they could have been bang, 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 and then way back there's somebody else. Okay, if you're going to try to measure them on times. And the idea is that under parametric situations, we've kind of assumed that our data is normal-ish. Okay? Now, we're not going to take a great deal of time on this. It's unfortunate. There's just the one chapter in a book. It's not actually a part of the curriculum that's a huge deal for most people. Most people, when they go out to study, business statistics and so forth, and they use them in the real world. For the most part, we deal with a lot of just normal, at least normal-ish statistics. That is, things are distributed pretty much like you'd expect. Okay. However, there are places and times when you'll see things that aren't distributed normally, and so there needs to be another way to do it. So, for the most part, these different tests will involve the ranks. Now, I think ranks are kind of becoming a bigger deal. Clearly, when someone asks you to rank your pain on a scale of 1 to 10. Now, I'm fairly tough. I mean, I don't really cry too much about much of anything pain-wise, physically pain-wise. I mean, you could pretty much break my arm and I'd wince, or I might drop a few swear words, but I'd move on. The other day I burned my finger pretty good, and it irritated me more than it made me mad more than it just like, oh, I'm going to sit there and cry about it or whatever, right? Or just be really upset about it. That said, I've watched 2 babies be born, and I don't know how she did that. I literally have no idea how she did that, because that would have been an 87 on a 10-point scale for me, okay? I am not that tough when it comes to that, all right? So we all have these different ideas. So I was at the doctor's here a while back for a physical, and on the one end it was the, how's your pain level today? Oops, that's supposed to be a happy face. And there was a happy face on the one end. And whatever, okay, so happy face. Never felt better. And it said underneath of it or something on this end, it's like, the world's ending. and anywhere in between, right? And I'm thinking to myself, well, you hear people talk all the time. They're kind of a little overly dramatic about things and so on. And you look at that, you're like, well, I don't know. Something else I use a lot is online recipes, right? So you see stuff that is ranked, 1 star or a 2 star or so forth, and whatever. And let's be honest. When you go to rank somebody's performance, how the person was at the store, let's say, for instance, if someone is provoked to actually turn in a ratings on a person, it's because they either did a terrible job or they did a phenomenal job. And there's very few people who are like, hey, let me just give you 3 stars out of 5 there. Very few people. Most people will give it one of these jobs. Oh, it's the best. Plus, whatever. Or it'll be disgusting. Like half a star. I mean, And so there's always this idea with rankings is that there's kind of a, yes, clearly this is better. We can probably all agree this is not the best dish, but some people will give it a 5 anyways. Some people will say this is a pretty lousy dish, but they still might give it a 2 for crying out loud. And so the idea is, well, okay, here's a bunch of lousy dishes, rank them in order, okay? Well, we can probably all agree that this one's on top of that one. By how much? Who knows? So that's the problem you run into with rankings. They're good for some things in that, I can put them in order, but I can't really decide if your ranking is the same as my ranking. A foot is a foot, okay? A meter is a meter. A kilogram is a kilogram, okay? They're very objective weights versus, or measures anyway, versus rankings, a little subjective at times. Okay, now, that said, all these things in Chapter 13 are going to be based on ranks in some fashion or another. Now, there is no rhyme or reason to which one I'm doing first, so I'm going to do the runs test first. I find it to be, well, quite honestly, the easiest one of the bunch. Okay, it is the idea of it's a test for randomness. Okay, and well, here's the thing. If you see, I remember this one year after I graduated from college, I substitute taught for, part of a year. I worked for my dad for part of the year too, and whatever. And so this one day, the secretary at the grade school calls me and says, well, can I need you to teach first grade tomorrow, or kindergarten, I can't remember. And I'm like, I don't know. She's like, come on, it'll be great. The kids will love you. And I'm like, nah. So finally she talks me into it. Boy, howdy. That's been 20 some odd years ago. It still freaks me out. I showed up and the little buggers were like, that's not how Mrs. So-and-so does it. That's not how Mrs. So-and-so does it. And then we went to line up for recess, and I kid you not, after I got lectured, because it's not Janelle's turn to be first in line, it's my turn to be first in line. Oh, sorry, Matthew. Sorry, dude. I said, go line up at the door for recess. This is literally how they lined up. I kid you not. Now, who lined these children up? Did they line up just randomly? No. Little kids do what? Yeah. Don't want to stand by the girls, boys, and then girls. Okay? Now, if I had lined them up, or Mrs. So-and-so had lined them up, it's very possible that we'd have lined them up, I don't know, something like this. Partly because first graders don't talk that much when there's a member of the opposite sex next to them. Keep them quiet for a few minutes, right? And that idea is that that's not random either. Okay, that isn't random, because it's going boy, girl, boy, girl, boy, girl down the line. Okay, it's that idea that up here there's not enough back and forth. There's just not enough back and forth. And down here there's too much. And somewhere in between there must be this happy medium. Okay, but either too many switches or not enough switches leads me to think that somebody has been messing with my data to some degree. Okay? And so what this test does is it goes in and it numbers the amount of runs that there are. So in the case of this top one, this is a run. That's one run. This is one run. So we have a total of 2 runs up here. Well, down here we got 1, 2, 3, 4, 5, 6, 7, 8, 9. For crying out loud, you got 10 runs. That's too many. That is, every time it switches back and forth, that's what we define to be a run. And so you might say to yourself, Jay, I don't think this is, you said it wasn't a Z or a T, but it feels like there's probably some lower bound and maybe some upper bound where if you are between those bounds, it's probably random. And if there's more than this upper bound or less than this lower bound, it's probably not random. And that's exactly how the test goes. That's literally how it goes. And you're thinking, well, how would I find these? Well, they're in a chart somewhere. I'll show you that in a minute. But then the question might be, the follow-up question would be, well, what will it depend on? Will it depend on how many, for instance, how many males and females there are? Yes, exactly. So this chart is in the back of your book. It's, in the back of your book. I don't know what page it's on for you, but I'll tell you what table it should be on. This should be, for you, table M in the appendices. And what it says is that, now this is a huge deal. Okay, it's set up thusly, where this is N1 on one side, and N2 goes across the top. And you're like, which one's which? It doesn't matter. Oh, cool, thanks. So, how many? Where's 1, 2, 3, 4, 5 males? So I'll put 5 over here, and there's 1, 2, 3, 4, 5 females over here. And we're going to play Battleship, basically. You're going to come down that column. You're going to come across this row. And you're going to find 2 and 10. Those are your upper and lower bounds. Nice, right? Now, if you read the fine print, this is huge. The fine print says you will reject H naught. Jay, you didn't write H naught down yet. Well, we'll get there in a minute. Reject H naught if, this is a big deal, if the number of runs is less than or equal to lower bound, or greater than or equal to the upper bound. Which, duh. Now, if you think about that for a minute, it's a little weird, and I have to say this because the way that these non-parametric tests work are a little weird. Because if this was a parametric test, if you were right on the line, you'd actually fail to reject. So on all of these non-parametrics, make sure you read the fine print of the chart. Okay? So in this case, we had 10 runs on the bottom one. Well, 10 is equal to this guy here, so what do? Well, you reject H naught. Well, what was H naught? I mean, we were rejecting it, that's cool, but what was it? Interesting, I don't know. So the data is random. The data is random. And of course, if you're rejecting that, the data is not random. Is not random. Random. Nice. So we're rejecting that the data is not random. Now, we can do another one here. Of course. Excuse me. Woo! Mercy. Yeah, I don't know. So let's see here. So you roll a dice a bunch of times. Oops, I don't know why I started using commas and then not commas, but whatever. You get the picture. They're just numbers on a dice. It's no big deal. How come you haven't got a... Oh, I already got a 3. I was going to say, how come I didn't get a 3 yet? I guess I already have one. Oops, that's tricky. That's a tricky dice, man. Let's go with a 6, shall we? 2, 4, 2, 2, 1. Now, you're like, I don't see a pattern here, Jay. Here's my question. Are the odds and evens random? Now, should they be? Well, yeah, I would hope so, because the probability you get an odd is 50%. Probability you get an even is also 50%. So this should be true. Now, let's go see what's up. Now, let's go up here and let's actually relabel these as even, odd, 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 even, even, odd, odd, even, odd, even, 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 odd. Now, mind you, I made this data up. I made it up. Okay, and so, you know, whatever. You know, I can do whatever I want to with it. But 1, 2, 3, 4, 5, 6, 7, 8. But when I make it up, a person can maybe even tell whether I'm cheating or not and making up data by testing this kind of thing. 1, 2, 3, 4. That's 1 run. What did I get? 8 runs. For God's sakes. Sometimes I swear I talk too much and don't listen to myself enough. Alright, try again, stupid. Oops. I'll take your eraser. There you go. Attaboy. Jiminy freaking Christmas. We have 1 run, 2 runs, 3 runs, 4 runs. There we go. Oh! 8 the first time. 1, 2, 3, 4, 5, 6, 7, 8 the second time. There we go. And we had a total of 1, 2, 3, 4, 5, 6, 7, 8 runs. Again, there's 8 odds and 8 evens, which, okay, out of 16, you're like, well, that makes sense. Yeah, gee, yeah, you're doing a good job of splitting them up. If you were trying to fool me, you did a good job, Jay, because you did half and half. Well, maybe, maybe not. So 8 and 8, I come down those columns and rows, and I get 4 and 14 for my upper and lower bounds. 4 and 14. Well, look where 8 is. 8 is smack dab in the middle of those guys. So we'll fail to reject H naught. Fail to reject H naught. Which means what? The data is random. Okay. And you can do this for other things too. For instance, you could get some data like this. Okay? And you're like, what the heck? I don't even know what that even means. Yeah, I don't either. So I'm going to punch this baby into Excel for just a second and just show you what's up. Please ignore the other pink ball. For some reason, this cheapo free cursor highlighting thing has decided to freak out on me. And now, instead of getting no cursor highlights today, I have 2. Only one of them works, but now I have 2 of them, so I should feel privileged, I guess. But that's what you get what you pay for, I guess. That's supposed to be 2, stupid. Try again. Attaboy. And 21. Bam. Now watch me do the following. Equals median. Now you know that half will be above and half will be below. That's not a surprise to us. Whoopsie daisy, what happened? Oh, I didn't finish typing median. I thought I had. Sorry about that. Boom. The median is 6. And so what we can look at here is that, well, we know 50-50 of them will be above and below. That's duh. But we could say this one is under the median or below the median. Above. Above. This is equals to. You're like, oh, what do we do if it's equals to? Well, there's a variety of methods for that. But the fact that it changes at this one here, you can just leave it off. Okay, because see how it goes from above to below. This is not the most exact science in terms of these things. Notice how it stayed above, so you just leave it as an above. You call that one run across there. There's a couple of methods for this, and again, not the end of the world. Okay. Again, not the most these tests. You realize them right off the bat. First of all, I'm dealing with rankings. I'm dealing with some stuff like this. It's a little touchy-feely. Do I include the median? Do I not? Well, just like making a lemon meringue pie, there's a variety of recipes out there. They all get you a pie, but they all are slightly different in terms of how they work the thing out. Okay. If I give you one of these, just be aware of that. So, had this gone from right here, a 14 to a 10, I would have just gone A and A, just like I did here on this one. So, it's 1, 2, 3, 4, 5, 6, 7 runs. So, 7 runs. And then for the U's, there are, and that's just one of them, 1, 2, 3, 4, 5, 6, 7. And for the A's, we're going to have 1, 2, 3, 4, 5, 6. And you could go 7 across the top and 6 down the side, or the other way around. In either case, it's 3 and 12 are my upper and lower bounds. So 3 and 12. And lo and behold, 7 is right smack in the middle of them. So what does that say? Reject H naught. And fail to reject, you dummy. Fail to reject H naught, which means the data is random. Nice. And by random, I mean, there's what I'd expect. it goes back and forth from being above the mean to, or the median, to below the median. Okay. Now, if this data was in order, that wouldn't be true, right? It'd be 1, 1, 2, 2, 3, 4, 9, and so forth, right? Oh, there's a couple of 6s in there somewhere. And what you'd find is that there's 1 run, and then there'd be like 2 runs. And that's not random. That would not be okay if it was in that order. And by the way, by definition, if you sort data, it's not random anymore. Okay, so that's kind of how those things go together. So there will be, ouch, stabbed myself with my electronic pencil. That was cool. But it didn't hurt that bad on a scale of rankings, just so you're clear with that. I just poked myself in the forehead with it. Anyway, there'll be another, I don't know, 4 or 5 videos of this stuff. Depends on if I put any of them together, so you'll see. And they all have the same kind of thing in common, where we're paying attention to ranks primarily from here on out.